Hey everyone, welcome to Cloud Masters. Today we're going to talk about Aurora Distributed SQL, or DSQL for short. AWS announced it recently at reInvent. We're going to talk about how is it different from regular, good old standard Aurora, advantages, disadvantages, what workloads are best suited for it. And we're joined by the perfect person to dive into this with. Kate Yavon is a former database specialist solutions architect, try saying that 8 times in a row at AWS, and now she's a database specialist here at DoiT. Kate, in your initial reaction, you said that this update defies physics. I can't remember the last time I heard defy physics in a database update in the same conversation. So maybe, tell us, is it really that big of a deal, or was that just the oxygen they pump into the casinos talking?
A bit of both, a bit of Vegas jet lag, but it is a massive announcement from AWS. To be fair, distributed SQL itself isn't particularly new, but for AWS to do it is, and it's a big game changer for them, purely because they've been competing with Cloud Spanner to some degree, and a bit of CockroachDB, which both have offered distributed SQL, but the way in which the Aurora DSQL version does it is fundamentally different, and I think it will allow even greater scale. So we'll kind of get into that, effectively what's so different about it as we go through this podcast.
One question. So we were obviously in the DoiT Slack channel listening to the keynotes and making our own snide comments along the way. And the first one that came up was exactly what you just said, and that was, did Amazon just announce Spanner, right? So is it the same? Is it you said that it's a bit of a game changer? How have they done it differently?
So the main way in which they do it differently is how it does like the transaction handling. So the transaction handling in Aurora DSQL is done via, effectively they create like a microVM, and by micro I mean maybe 1/100th of a CPU. We're talking absolutely minuscule, like almost like Lambda. How Lambda just takes exactly what it needs. So effectively, you get an isolated VM for every transaction, which means that can scale. So typically, you end up with any relational database. As you have connections coming in, they take a small amount of compute, memory, resource from your database layer, and over time that just builds and builds, and eventually you just get totally blocked out. A write will lock the reads on like the certain rows, so you can't access them, and you end up having it basically you can't scale infinitely. You will always end up with a limitation. I'll come back to limitless because I've just used the word limited, and we'll talk about limitless as well in a bit and why this isn't. But so what this does by having an isolated VM is you effectively have a small database engine that runs in a VM for each transaction. So none of them even ever know about any of the other transactions going on. There is effectively no locks in the database. So every read goes to the storage. Effectively, it basically gets a timestamp when you start that read. It creates a VM, it goes to the storage, and it pulls all of the data that you need consistent with your timestamp. So under the hood, you're running Postgres. So Postgres has effectively the MVCC system, which means that it has different versions of the data at different times. As it gets changed, you effectively, you don't delete that data. It just kind of gets hidden, and the pointer to it gets removed, which allows you to do rollback and so on and so forth. So effectively, you go and get the version of your data that you need for your transaction pulled into your own VM, where you can work with it however you want. So you're no longer touching the database at that point. You're completely isolated, running in your own personal database. You can then do whatever you want to that data. You can make changes. You can, basically you can then start to modify. You can do updates. You can start to do writes. And it's not until you hit the commit button does that then entire transaction get pushed down in one go. So that's like the big difference. So neither Cockroach nor Cloud Spanner work quite in the same way. They have a similar way of managing the transactions, but they don't create these entirely individual VMs, which then I think in theory gives Aurora DSQL so much more scope to grow. There's no one layer that could ever bottleneck. Everything can just grow independently of each one. So theoretically, it could handle almost unlimited numbers of connections, and in theory, again, storage. But we did talk about Limitless. I mentioned Limitless a little bit. So a lot of people are asking, does this just replace Aurora Limitless? So I think last reInvent, actually, they announced Aurora Limitless, which was effectively a database. It's not distributed. Limitless allows you to do sharding. It does automated sharding. So a little bit similar, I suppose, to DynamoDB in a way. There's different sharding, which allows your storage to scale limitlessly, but not the connections. So it still runs effectively Aurora standard Postgres. So you still have the same problems with locking, with consistency, and with transactional growth. So if you have a huge number of connections running small transactions, DSQL is going to be far better for you. If you want a database that's absolutely phenomenal, like multi-terabytes, petabytes in size, but maybe much larger, but fewer transactions or connections, then Limitless is still probably your better choice.
We don't see yet anything on the roadmap about combining Limitless and DSQL to make something that scales everything everywhere all at once.
No, not yet. I would wonder if they could work. So again, a way that like Aurora DSQL manages that scale is by how it does locks. So it does optimistic locking. Now, optimistic locking is very different to how most relational databases work. Most relational databases, when you start your transaction, effectively the rows that you need get locked in the database. So nobody else can access those, or you can't write at the same time. But with Aurora, that only happens at effectively commit. So what that means is if you make a change, so when your transaction starts, if you're trying to make a change and somebody else has already made that change in their transaction, your transaction doesn't know because they're entirely isolated, which then means that falls over. Because that's so different to how every other relational database on Earth works, I think trying to combine those two just isn't going to happen because of the way in which how effectively that like the transaction models work. But in theory, I'm not actually sure what the limits are yet on DSQL. I mean, it's up into the terabytes anyway, which is going to handle the vast majority of use cases. And if you are loading petabytes of data, I would start to question whether you would need to do something so distributed as DSQL, because that's much more designed for extreme high concurrency and throughput as opposed to massive volumes.
When I was trying to make sense of optimistic locking, I was thinking of just how we can edit a Google Doc at the same time, or Figma design. And so I guess that has implications, like as you hinted at, into I guess what happens, how are failures detected? Like is it just if Sam and I change the same field or same column in the same table or database and we hit commit, then it just fails. It doesn't do which transaction happened first or whatever. It just fails the whole thing.
Yeah, no, it does. So effectively, every transaction has a start time, and the one which effectively started first gets priority. So that's all being managed. So what happens is when the commit happens, this is always better with a picture, but I'll try and explain it through. So effectively, you've got each individual VM that's basically talking to basically each individual VM, your transaction. And then there's effectively a query executor, which is what's running the transaction underneath. So effectively, that's a bit like your, what's the word I'm after? Like effectively the optimizer, the thing that runs the query, that basically handles retrieval of data and whatever you need it to do. What you next have is an adjudicator. And the adjudicator's job is to work out which transaction is allowed to run and which isn't. But the adjudicator only gets called at commit. So when you hit the commit button, the adjudicator knows what transactions, what rows have been edited or modified since the start of your transaction, because it keeps that log. So it knows whether or not you're going to be changing any of the same rows that have already been changed. If it does find any, then your session gets rolled back. If it doesn't, it moves on and then it goes on to a journal. And the journal sits multi-region as well. So when your commit hits, that's when it then goes into multi-region. So the minute it hits the journal, that's similar to writing it to a redo log or an audit log. So that's the point when it becomes consistent. That's when your entire ACID transaction is complete at that point. So that's sort of really how it handles things. What this does mean is that you potentially will have more failed transactions. So rather than transactions kind of waiting now or failing at the beginning of a transaction, which would happen now, if you tried to do an update or a select for update, the first thing it will do is go, hey, are these rows okay for me to lock? If you can't lock them, your transaction fails at the start before it even begins. In this version, your transaction won't fail till the end. So if you ran a transaction that, I don't know, you spent hours, you pulled in loads of data, you did loads of sorts, you did loads of orders, loads of wonderful data crunching, and then after an hour you tried to commit it and it failed, you'd probably be a bit cross. Which is why Aurora has a 5-minute timeout. So DSQL will only allow you to run a transaction of 5 minutes. That's a hard limit as things stand. You will not be able to adjust that. That may change in time, but as of launch preview, it's 5 minutes max. So really, DSQL is not very good for analytics workloads. The kind of ones where you would run a huge query that could take hours or days to run. That's just not going to fly. Yeah, 5 minutes only. So it really is a transactional. It's an OLTP database only.
So it's like, I was gonna just so I understand, I guess when we talk about, I think I imagine the opposite is called pessimistic locking. This is optimistic locking. So you're trading the guarantee that everything will work for the first time for the ability to handle many more users at once.
Yeah, exactly right. So the idea is that if you actually go and have a look at most transactional databases, huge throughput, they don't have very many updates or writes that affect the same rows at the same time. In fact, if you've designed your database correctly with good use of keys, you really shouldn't have very many rows being updated simultaneously. And that's really what Aurora is designed for. If you look at most OLTP systems, let's talk about something basic. Session handling for a website. I mean, you probably want to use Dynamo for that, but regardless, the only rows you're going to be updating are to do with that user or that session. So as long as you've got good segregated IDs, you shouldn't ever have two different sessions trying to write to those same rows. Same with things like another good use case that's been cited, things like online gaming, maybe with leaderboards. And again, you can have the same thing. You really shouldn't have multiple processes updating a single row. So even banking, you've got a bank transaction system. Well, every update, every write should just be to its own row. There shouldn't be really more than one thing writing to the same row at the same time. So those are the kind of use cases that they looked at. And they did, obviously, AWS has spent a long time trying to build this out. The fact this is quite a few years behind things like Spanner or CockroachDB, they've been able to kind of maybe learn from some of them, well, I wouldn't say mistakes, but learn from some of the issues that they hit and have been able to find ways to try and get around it. So I was chatting with somebody slightly unofficially while I was at reInvent. And basically the idea is they would think that probably about 90% of transactions never actually write the same row at the same time. So therefore, in 90% of cases, optimistic locking is by far the best way to go. And for the other 10%, either this isn't going to work for you and you just need to use a different database because it's not suitable, or you could try to change your application slightly to handle this. The way in which it's recommended is you now need to start bringing a lot more retry logic into your app. Even if you have an app that meets this model perfectly, you want to have it anyway. So effectively, you want to try things like exponential back-off of retries, automated detections. Effectively, so you would need to do some application coding because even if you're running this perfectly, I would still expect a lot more failures than you would have normally.
One of the big things you mentioned about the adjudicator piece and the timestamps on the records here. One of the things that the transaction, not the record. One of the things they mentioned during the announcement was this new time service, which is the most accurate clock ever built in a computer or something along those lines.
Yeah, something like that. Yeah.
And that's what underpins all of these decisions.
That's
is that
right.
timestamping.
Exactly. Yeah, so if you think about it, a second is an extremely long time in the computing world. Nowadays, even a millisecond is probably too long. So the only way you can have such a high rate of transactions that could all be running in, of what we can tell, a click of time needs to have such an incredibly accurate clock. And also, this is potentially going global. So that clock needs to not only be accurate, extremely accurate into multiple decimal places, it also needs to be exact in every single region in the world. Because if you've got one transaction out of sync, so we haven't really mentioned this, but this is active multi-region. So you can have customers running in Sao Paulo or Singapore when it goes live that could both be writing to that database simultaneously. So they need to be absolutely in line. like the slightest change of time clocks between those two systems and those two regions will be catastrophic, because then the adjudicator can't know which transaction happened first, or it will think in Sao Paulo it happened first, and Singapore will think the same, and then you're going to end up with effectively a conflict. And I have no idea actually how DSQL would handle that. If there was a clock mismatch in some way, I'm sure they have thought about how that gets handled, because it can, but I don't know how that would be dealt with. So you can start to see why that clock and why that's sort of like new. It's not an atomic clock, but why that new time sync method is so critical.
I was thinking about in the past when you were bringing up the limitless SIM, and you're asking me why not combine it, and I guess I was already thinking, it's not Aurora's DSQL. It's not really suitable if you need to do lots of complex joins across tables, and so
Yeah, it really is a cut down. A lot of the complaints that I've seen already have been, well, where's the support for anything Postgres? And they're really right. So to make this work, things like foreign keys have had to be removed. The main reasons, if you think about how a foreign key relationship works, when you try to update, if you update child rows, you have to make sure there's a parent to match. So that obviously involves more locks. You have to go and test the parent table to make sure that actually exists. So that would involve locking, which you can't have. So as a result, you can't have foreign keys. To be honest, even though I'm probably going to get a lot of heat from DBAs, I actually don't like foreign keys in databases anymore. I think their time has slightly gone, the same as having things like stored procedures in databases. Where possible, your application should be the one that governs it. It's the application that cares about data consistency. The database is simply that. It's a place where your data lives. But you would need to, if you are relying on that, you would need to push that reference integrity out into your application layer, and you'd have to make sure that your application is maintaining that model. For many customers who do rely on cascading of foreign keys and use that in their code, that's going to be a problem. You're going to have to do an awful lot of rewrites. And again, stored procedures, not going to be supported. So, you've got some real limitations. Effectively, this is about as close to SQLite as you're going to get. It's got a bit more. It's Postgres compliant, but less so than Standard Aurora. But AOS are saying they're going to try and roll out as many Postgres features as they can. But this actually leads on to another question that I had while I was out in reInvent, which is, are they going to be deploying a MySQL version? And as things stand, the answer is no. So the aim is that this only uses Postgres because of how Postgres operates. So basically, because of the MVCC, the ability to have multi-versions of your data, and because of how Postgres works on the hood, because of its open source, also massively important, and its kind of changeability, you can recode Postgres very easily, and put in additional plugins, extensions. Postgres just kind of found itself as the right home for these, same reason why Aurora Limitless. So there's no real expectation that there will ever be a MySQL version of this, because whilst this is Postgres, it's such a light cut down version of Postgres that it could be anything. As long as you're running ANSI specific, like ANSI syntax SQL, it will work. And that's the point, that they're trying to get people away from picking a database like engine. They want to get people away, by the sound of it, from using Postgres or MySQL or Oracle or SQL Server, and instead just pick the feature set that you need, and you map to whichever database in AWS's suite of databases that works best for you.
I want to come back to one thing you said there, Kate, and in particular, I think I can see what you mean with the foreign key thing upsetting a few DBAs. It almost sounds like, going on my very simplistic view of databases, it almost sounds like AWS is trying to force everyone to use a SQL compliant version of Dynamo that's distributed here. I mean, if you're managing all of the relationships in your code, if you're managing that everything is proper and accurate and so on in your code, and not using the database engine for it, that's kind of the whole reason relational databases existed, so that the code didn't have to do this stuff, right?
Yep, absolutely. You can still do like table joins. You can. They are still possible to do joins, but you can't rely on the foreign keys to keep those relationships. But obviously, you can still join. You don't need foreign keys to do a join. So you can still join. But yes, there is that. It is definitely a lot of people have just gone, so it's a SQL compliant Dynamo then? And the answer is kinda.
Yeah.
So
There's still multiple tables and there are still joins, but
yeah.
yeah.
And again, so Dynamo, as you know, if you do data mod, so anyone who's tried to work with Dynamo knows that as actually an application designer, Dynamo can be a little bit tricky because you have to define all of your data access paths first. So whilst you should probably do that anyway, but a lot of people don't, or things change over time. But on Dynamo, it's an absolute. You must define your data access patterns. If you don't, you haven't got the right indexes in place. You haven't got the right indexes, you can't get the data, or you have to start doing table scans, which are horrific. So you end up being a little bit stuck. And if you make a bad decision right at the start, you're basically a bit screwed with that forever. It's not easy to just go and change a bit on Dynamo. You can add in a GSI perhaps, an LSI, but you're fundamentally a little bit constrained by your original decisions. So therefore, there's still a space for customers that maybe don't know exactly what they need or what they want, or they think they do, but then actually the developers decide they actually want to do some ad hoc querying, or they do want to do an OLAP type query, even though I've advised them not to. That's the real world. And so that's the space that this has. It's not just the code, the programming languages that's being used, or like the coding. It effectively gives you more freedom. You can still do schema changes. You can still add in columns. You can still make, you can still just go and do a massive select over every single table if you wanted in a database. The things that you can't do in Dynamo. So this works well. It's a bit of a halfway house, perhaps, between Dynamo and between a traditional relational database. But I think this works quite well I don't think this will work for any customer that's maybe using a COTS or like a bought service. Be interested to see if like an off-the-shelf application will ever be compliant with Aurora DSQL. I suspect possibly not. But if you're building it in-house and you can take on a little bit of that work yourselves, then I think Aurora is a really good halfway, especially with customers that maybe don't want to go fully to DynamoDB for whatever reason.
But this is, I mean, essentially it's an entirely new, it is an entirely new product. Does that mean that customers, if they want to, so what I'm thinking behind the scenes, if I grow to the size that I need a database like this, I'm probably not going to grow to that size overnight, right? I'm probably going to my product is growing over years and I'm distributing it more around the world and so on. Does that mean that they're going to have to run something like DMS to move all their data from their existing Aurora, Postgres, SQL, whatever they've got, into now a DSQL environment?
Yeah, so because we're only in preview, I think we're still waiting on some better migration methods. I'm hoping that there will be a one-button click, migrate to DSQL.
It never
But I
is.
suspect that won't happen because, as you point out, and as we've talked about, there's some fundamental differences. So it would be very difficult to do a one-click and then have all your foreign keys dropped. All your
And your
triggers
standard procedures
dropped. All your code in your database just deleted. It doesn't support for JSON, for example. So I think that could be like a bit of a challenge to migrate across. So I suspect that DMS will likely remain probably the only sensible way to migrate if you want to move across, as opposed to just starting new.
We're just like, by the time we're recording, a week after it was announced, roughly, maybe 8 days if we're being extra precise. But have you had any conversations already with customers about switching to this?
I've had one customer basically just asking for a little bit more information about it. Obviously, like anything, a lot was left out of the launch, which is pretty normal. So they was basically asking about things like timelines and, any specific gotchas that maybe weren't advertised by Matt Garman at the time. But I expect this to trigger a lot more. I think there's a few customers that I'm going to go out and talk to proactively, just basically knowing their workloads and knowing what they are doing and knowing that they're trying to grow globally. I think this could be worth having a conversation with them about. Again, they may get a little bit blocked by some of the missing features. So I guess I need to go and have a deeper conversation with them about how does the application look? Could they live with some of these? Or is it just too much code rewrite for them?
If I have it right, this is best if you have a system or an application that needs to handle a lot of users at once, give very fast responses, and process a lot of quick and maybe simple data changes. And you mentioned, I think, the leaderboard in like a gaming situation. So gaming is an industry that could be ripe for this. Banking, online shopping, basically anything where people are making maybe small updates. But you just have to be okay with sometimes having to retry when things fail.
Yeah.
And structure your data more simply. So all that to say, for those who would be right candidates for this, so the use cases in the match, what changes do you anticipate they would need to make? Like they say, Kate, I want your help, or I need your help to switch to this. What do you anticipate being at least the minimum change that they need to make? Let's not think worst case scenario, but let's think maybe average.
The first thing will be look at what your longest queries are. So with a 5-minute absolute cutout, you're going to need to make sure that your queries don't take longer. In theory, DSQL should run faster because it's not doing the locking, because you get your own sort of dedicated transaction engine to run things. So in theory, it should be faster, but in theory and reality are often not quite the same. So I would start by looking at things like performance insights, go and have a look at your longest running queries. If you are coming from MySQL, you could look at things like the slow query log, for example, set that up with a 5-minute, 600, I can't do maths. Someone do maths for me. 300-second timeout on the slow query log. And then you'll be able to see if it's empty, you're all good. You're not going to hit that absolute hard limit. Again, then it is starting to look through your application code really, and how much are you relying on foreign keys. If you're already doing a lot of that in-house, then again, I don't see any of these things being a blocker. Any other one would be things like JSON. So currently JSON's not supported. I'm very certain it will be coming fairly soon because it's pretty massive these days for so many customers using JSON. So I'm hoping that's going to come. But if you're using it right now, it's not going to work. And again, sadly, especially given the massive push and how many things we're talking about Gen AI, it doesn't support PG vector, which is a real shame. So you can't do your vectoring, you can't do your embeddings and use that for a lot of Gen AI. So if you're using things like Bedrock or SageMaker and you want to connect it to this to hold like embeddings, you can't do that right now.
Well, things are always changing, so I'll be sure to update the description of this wherever this is hosted on YouTube, etc. Because
yeah, I was going to say, as of release date, these features aren't supported.
And you wrote a blog post too, so I'm sure that blog post will be updated as well. And we'll link it in the description and whatnot. So right now, you want to learn more. You have AWS documentation. You have your blog post, which will be updated. You have other talking heads maybe that are giving their opinions on this. But did I miss anything? Of course, if you work with DoiT, if I talk with someone like Kate, right?
Yeah. Makes Sam's life busy.
Yeah, I was going to add to that. Since you introduced me in, that this is a very typical AWS release, right?
Oh, yeah.
It comes out as bare bones and
minimum
a
viable
lot of people
product.
say MVP, exactly that. So if we were to re-record this in 6 months' time, I'm sure you would see a huge change in the feature set, support. Whether or not that would include things like PG Vector, whether it would include MySQL support, no idea. I assume not on that latter one. But maybe we should put a tentative calendar date in the diaries and make sure that we review this in a while and see how successful it's been and which big customers have gone and done case studies on it and what they've found with it.
And I think and I think without wanting to sound a bit like an AWS fangirl, which I am, but I actually really like the approach because I think there's this idea that every time you build a new road or every time you extend a road, the traffic just moves exactly back to where it was before. You're constantly playing kind of catch up. And I think actually features of new services are almost the same. So if you make something available, people just tend to use it because it's available. And it might not actually be needed. And it may just be that with a small amount of changes in your application, you suddenly don't need 3/4 of the features that you had before, but without being rude, but kind of a little bit of laziness or, a lack of desire to maybe make those changes just forces you down the same road. You make the same decision using the same tools. So actually by giving an absolute bare bones, almost no features release, AWS can then start to see actually, well, what is actually missing? Like when customers are trying to use it, what's the feedback, genuine feedback, not assumed, but real feedback from the field of people that are trying to use this properly? And what do they need? What are the actual missing features? Not the things not just porting it again from Postgres, but this is a new database. So let's do something different. So I always kind of like that version. It would have been nice if there'd been a little bit more Postgres, like extension support. I think that for me is a big one. I can understand why they aren't supporting foreign keys. That's a pretty obvious one. But things like JSON and some of the Postgres extensions not being there is a bit of a shame. But fingers crossed they'll be coming soon.
I can tell you that the platform teams will all have the same problem with every release. With DSQL as they do with every release, and that is no CloudFormation or Terraform support.
Standard. Of course not. It's coming soon.
If
you want me to get version 2, then we'll have support for version 1.
Would you rather the product was available to test, or would you like to wait the 6 more months until someone's written a CloudFormation for it, right?
Yeah.
Sorry.
Yeah, I know. I always think, how long could it take to write CloudFormation? But obviously it's way more complex than it seems to be. Otherwise, I'm a big believer in, if it was easy, it would be done.
So I think we covered everything that we could possibly cover a week after an announcement of a pretty big new product / subproduct of Aurora. But so we'll see what happens in the next 6 months or so. It's worth revisiting, recording something new. But in the meantime, thanks for listening, everyone. I'm gonna link Kate's great blog post if you're more of a reader than a listener as far as learning. And thanks for listening. So that's watching.
Thanks, Kate. Ciao.
Bye, everyone.
If they're more of a reader than a listener, have they gotten this far in a podcast?
Dude, I'm just that's why they make me the host.
You could have made a read replica joke right in there.
Right. Oh man, sorry.
Oh, there was a read endpoint joke there, just waiting.